All right, everyone, welcome to another riveting day of Algebra 1. Today you will be taking Cornell notes, so you should already have your notebooks on your desk so that we can get started. Your topic for today is forms of linear equations. Your essential question is, how do you use given information to write an equation in slope-intercept form? Now, one responsible person in your class should be near the computer so that they can pause it whenever you feel like we need to write this down or it's moving too fast for us. And so right now, whoever you are, please go ahead and pause the video so people can write down this question. All right, so now that you've written that down, the first thing that I want to do is write down 3 equations for you. The first is y equals 4x plus 7. The second is y minus 15 is equal to 4 times x minus 2. And the last one is 4x minus y is equal to negative 7. All 3 of these are equations. You see that they're all equations in 2 variables because each of them has x's and y's. All of them are linear functions, which you'll know ways to figure that out later. But there's one more thing that they all have in common. Can anyone tell me what it is? Yes, that is right. All 3 of these represent the exact same function. These are each just different forms to write the equation for this function. Think of it as speaking different languages or just different words for the same thing. So this bottom one is written in standard form. This one here in the middle is in point slope form. And up here at the top, this should look very familiar to you because this is the form that we use the most because we love it. It's very useful. Slope-intercept form. So I don't think you fully appreciated what I said. So let me say it for you one more time. Although all 3 of these look different, they're all exactly the same function. There we go. That's the reaction I was waiting for. You should be a little bit impressed by that. Over the next week, we're going to spend time talking about all 3 of these forms. But today, we're going to focus on slope-intercept, which you already know tons about. It's just a matter of perfecting your knowledge. So first off, let's talk about how to find the equation in slope-intercept form from a table. Not quite that type of table, though. We're talking about an algebraic table, a table that has some values that we can use, much like this one. Something that has an independent variable or some x values and a dependent variable or some y values. It's important that we be able to tell the difference. But we're trying to write this into slope-intercept form. Y equals mx plus b. To do that, we have to know m and we have to know b. It's that simple. There's a multitude of ways to figure out m, but there's one that's common that we use for tables. What we like to do is figure out how much we're changing by on each side of the table. So you pick 2 random points. They don't have to be right next to each other. They don't have to be the first 2. They don't have to be the last 2. It doesn't have to be the first and the last. The beauty of a linear function is the slope is the same anywhere. So I'm just going to pick these 2 points right here. And so I look at the change in the y values, or delta y. So as I look, when I go from 65 to 70, I'm adding 5. When I go from 40 to 60, I'm adding 20. That's my delta x, because this is a change in some x values on this side. So now my slope is equal to delta y over delta x, which is 5 over 20, which is equal to 1 over 4. Now, if you're using a calculator, you might call that 0.25, but we prefer to use fractions in Algebra 1. But here's the point. We're already halfway there. I figured out that my m value is 1 over 4. Now my job is to find b. To find b, what we can do is plug in the information that we do know. So once again, we're dealing with y equals mx plus b. So this is really 4 different pieces of information. There's a y value, an m value, an x value, and a b value. We don't know b because that's what we're looking for. We just figured out m, which is 1 over 4. But we need to find some x's and some y values. Now, as I look at this whole page, where might I find some x values and y values? Ah, you're right. There's a whole table here full of x values and y values. Just pick some. As long as the x and y value go together, so like this one and this one, or this one and this one, you'll be fine. So pick any x and y value that you want to. So I'll just stick with the first one, an x value of 20 and a y value of 60. So I'll plug in 60 here for my y value. I'll plug in 20 for my x value. And now I have all the information that I need to solve for b. So 1/4 times 20, that's just 5. So 60 is equal to 5 plus b. And then I subtract 5 from both sides. So 55 is equal to b. So now I have my b value as well. b is 55. So if m is 1/4 and b is 55, I can just plug those things in for m and b. So y is equal to 1/4 times x plus 55. Now I can use this final equation to predict any of the points on this table or any points that come after or before. Go ahead and pause the video here to write down this information. All right, that table is probably the hardest example that we have here. So moving right along, let's talk about ordered pairs. Very, very similar to tables. The reason that I say that is because I have a bunch of x values and I have a bunch of y values. And once again, I just picked 2 points. It does not matter which 2 I choose. You just need to pick something. So I'm going to focus on just these last 2. Not for any particular reason, just because I can. You have choice over precious few things. This is one of them. All right, and so I'm going to use these 2 points, and I need an m, and I need a b. Why do I need these 2 things? Because I'm trying to write this in y equals mx plus b. So let's find m. Once again, I'm going to rely on one of the methods that I have for finding slope. This time I'm using the slope formula. So I like to use parentheses to keep everything straight, because there's going to be lots of numbers coming through here. I also like to label what is x2, what is y1 over on this side, just so I remember. So I'm labeling up above, so I'm going to call this x1 and this y1. I'll call this x2 and this y2. And now I can just plug everything into the right place. So let's see, y2 is -1. Y1 is +2. X2 is 2. And X1 is 1. And now it's just a matter of simplifying. -1 minus 2, that's -3. I know that you all agree with me on that. 2 minus 1, that's a +1. So now I just simplify. -3 divided by 1 is just -3. So my m value is -3. But I still need to find b to get this into slope-intercept form. What's that? You see a way that I can save myself some work? What? They've basically given me b? Let's take a look up at these ordered pairs. One of these ordered pairs over here is special. One of them gives me a lot of information without me having to do any work. Take a very close look and figure out which one it is. Have you figured it out? Ah, yes, this point right here in the middle. This point here in the middle is 0, 5. Because the x value is 0, that means that this is my y-intercept. So my y-intercept is 5. That saved me several steps of work just by knowing what a y-intercept looks like. So now I can plug in my m and I can plug in my b. Y is equal to -3 times x plus 5. And now I have an equation that can predict any value here. This is a good place to pause the video and be sure that you have all of the notes that you need. All right, so we've talked about tables, we've talked about ordered pairs. Our next example here is writing an equation from another equation. So sometimes we have an equation in one form and we need to move on to a different one. So let's try this example. We have 3x plus 5y is equal to 15. Now, those of you who've seen me do this before, you know you can draw this vertical line here, but you don't have to. For some people, it just helps to keep things in order. The first thing that you move out of the way, though, is always the same. You try to move those x's to the other side. So I subtract 3x from both sides. 3x minus 3x, that cancels, and then I have 5y is equal to, well, is that 12x? Is that negative 18x? Is it 347x? Is it 0? Oh, you're right. These are not like terms, so I don't combine them. So this is just 15 minus 3x. And now I can divide both sides by 5. 5y divided by 5 is just y. 15 divided by 5 is 3. Minus, I'm just going to write this as a fraction, 3 over 5x. And now my very last step, which a lot of people forget, I need to make sure that this x term comes first. So I just switch this around. Y is equal to, this 3/5 x has a minus sign in front, so it becomes negative 3/5 x. This 3 was positive, so that's plus 3. Now this is my final equation, because I have my m value of negative 3 over 5, and I have my b value of a positive 3. And y is by itself. So this is slope-intercept form. Go ahead and pause the video here. Be sure you have all these notes written down. Be sure that you know how to do this. All right, and now we're going on to our last example, which is hardly even worthy of its own page. Why? Because it's so straightforward. You've done it so much, and I apologize for wasting your time with it. But we're going to write this into slope-intercept form. Y equals mx plus b. Once again, I need to find my m, and I need to find my b. That's not going to change. We're always looking for the same information in every example. So to find m in this case, what we can do is called rise over run. So I don't have to use a slope formula unless I want to. I don't have to find delta y over delta x unless that's what I like to do. I can just use this picture of the graph. So I pick 2 points, which are already chosen for me here, and I find out how much I change vertically and how much I change horizontally, my rise and my run. So starting at this point, I rise 1, 2. So my rise is 2. I run 1, 2. So my run is 2. That means that m, or rise over run, is equal to 2 over 2, which is just 1. So my m value is 1. The next part is even easier. My b value is just where I cross the y-axis. So if I'm looking at this graph, first I find the y-axis. Well, this is the y-axis. And now I look for the place where I actually cross it with my line. There it is. I cross right there at a y value of 1. And so my b value is 1 as well. So if I plug in my m and my b, y is equal to 1x plus 1. And now this is my equation that allows me to find any point that's on this line. That's the value of an equation. Any x value you give me, I can tell you what the appropriate y value should be. So this is a good place to pause. Be sure you've written everything down. And now, my very last slide is just to tell you that you are a fantastic audience. I know that you took some really great notes and you are ready for the worksheet that's about to be passed out to you. So good luck. Refer to your notes as you need them.